All right. So, an identified compound is 17.55% sodium, 39.7% chromium, 42.7% oxygen. What's the empirical formula? So I'm going to need to have my periodic table handy. My magnet goes. Okay, so first thing we want to do is we want to take all these percents and just change the percent to grams, right? Because we're pretending we've got a 100-gram sample, right? So we can just take all these percents and change them all to grams, right? Because if I've got a 100-gram sample and it's 17.55% sodium, that means I've got 17.55 grams. So now we're going to convert grams to moles for everybody. So 17.55 grams Na times, sodium is 22.99, right? 22.99 grams per mole. And now let's do chromium. 39.7 grams chromium, and its molar mass is 51.996. And oxygen, 42.7. 15.99 grams per mole. So now we do a little bit of arithmetic. We're going to carry out a bunch of decimal places here so that we can identify which one's the smallest. 17.55 divided by 22.99 gives me 0.76338. Let's just carry out lots of decimal places we can round at the end. 39.7 divided by 51.996 is 0.76352. And then 42.7 divided by 15.99 is 2.6704 moles. So these two are essentially the same, right? 0.76334 essentially versus 0.76335. Really, so we're not going to see a huge difference between these two. So really, depending on how many decimal places you carried out, you may have not even noticed the difference between those two. So we divide everybody by the smallest number, 0.76338. So that's going to be 1. 0.76338. That's going to be 1. 0.76338.76338. That gives us 3.5. What do we do if one of our substances ends in 0.5? Because we don't round that up, we don't round that down. That's 3.5, right? So how do we get rid of that half? We double everybody, right? A lot of students will double this one and they'll forget to double the other two. They'll just say, oh, I only need to double the one that ends in 0.5. But you have to double everybody. Okay, you've got to multiply the whole shebang by that factor. So times 2, times 2, times 2. So that's 2, and that's 7. So that's where we get Na2Cr2O7. Does that make sense? Do you see where you made your mistake if you made one? Most common mistake is they'll double this one and they'll just forget to do it to the other two. Is that what happened here?
It was like when we did the rounding part for after we found the moles of the oxygen, instead of doing 3.5, it was 3.49, so I just was 3.4 and we rounded to 3.
Oh, okay.
You took 15.99 and we took 15.999 and it came out 2.6 is what it came out on our end.
Oh, okay. Okay.
So that's why I was the.
Okay. Yeah, if that comes out to be 3.49, we would call that 3.5. Yeah. Do we feel good about this one now? All right. Let's look at the other one. What is the empirical formula of a compound that is 89.14% gold and 10.8, excuse me, 0% oxygen? So again, the first thing we want to do is we're pretending we've got a 100-gram sample, right? So if a 100-gram sample, it's 89.14%, that means I've got 89.14 grams and 10.8 grams. So we're going to first convert grams to moles. So 89.14 grams AU, and I don't remember its molar mass off the top of my head. We're on 96.97 grams per mole, and 10.8 15.998 is what you're using. 15.999 shouldn't make a huge difference. Let's see what we get. Calculator. All right, 89.14 divided by 196.97 gives me 0.452. Let's go 45256. And 10.8 divided by 15.999 gives me 0.675. 6750. Okay, so this one's a lot easier to choose the smaller number. Okay, so 0.45256 divided by 0.45256. This gives me 1 divided by 0.45256. That gives me 1.49 again, which I'm going to call 1.5. Right? Anytime you get that 1.49, you should call that 1.5. Because we're going to end up having to do the same thing we just did in the previous problem, right? Anytime you get a 0.5, even if it's just one of them, we have to double everybody. Times 2, times 2. So that gives me 2. That gives me 3. So that gives me AU203. So if you had gotten that 1.49, call that 1.5. Just like if you get 1.29, call that 1.3, right? And what would you do if you get a third? You'd triple everybody, right? Does that clear up the issues? Good. Any other questions on this? How do we feel about it overall? Feeling good? Good. And then